12th Science, Chapter 5, Surface Chemistry, Part 1. Adsorption and Factors Affecting Adsorption. Hello students, I am Madhusina, your chemistry teacher. Do watch my YouTube videos, like and subscribe it for further notifications. In this video, we will be studying some of the important phenomena which are taking place at the interface. That means on the surface. So basically, we will be talking about surface chemistry. Surface chemistry deals with phenomena that occur at the interfaces or surfaces. The interfaces or surfaces is represented by separating the bulk phases by a hyphen or a slash. The bulk phases that we come across in surface chemistry may be pure compounds or solution. The interface is normally a few molecules thick, but its area depends on the size of the particles of the bulk phases. There is no interface between gases because of their complete miscibility. Many important phenomena which are noticed in our day-to-day life are corrosion, electrode processes, homogeneous catalysis, dissolution, crystallization, etc. at interfaces. Adsorption is essentially a surface phenomena. In this process, accumulation or concentration of the substance takes place at the surface of the solid or liquid as compared to the bulk phases. The molecular species or substances which concentrate or accumulates at the surface is termed adsorbate, and the material on the surface of which the adsorption takes place is called adsorbent. Solids, particularly in finely divided states, have large surface area and therefore act as a very good adsorbents. We come across a number of examples of adsorption in day-to-day life. Gas molecules like oxygen, hydrogen, carbon monoxide, ammonia, etc. gets concentrated at the surface of charcoal. That means the gases are adsorbed at the surface. When a solution of organic dye is shaken with animal charcoal, the molecules of dye thus gets adsorbed on the surface of charcoal. Aqueous solution of raw sugar when passed over the beds of animal charcoal becomes colorless as the coloring substances are adsorbed by the charcoal. The air becomes dry in presence of silica gel because the water molecules get adsorbed on the surface of charcoal. The process of removing an adsorbed substance from the surface on which it is adsorbed is called desorption. It is necessary to understand the difference between adsorption and absorption. In absorption, the substance is uniformly distributed throughout the bulk of the solid, whereas in adsorption, the substance is concentrated only at the surface and does not penetrate through the surface to the bulk of the adsorbent. Hence, absorption is a bulk phenomena, whereas adsorption is a surface phenomena. In absorption, the substance is uniformly distributed throughout the bulk of the solid, whereas in adsorption, the substance is concentrated only at the surface and does not penetrate through the surface to the bulk of the adsorbent. For example, water vapors are absorbed by anhydrous calcium chloride but adsorbed by silica gel. In adsorption, the particles of the adsorbent which are present on the surface are not in the same environment as the particles present inside the bulk. Inside the adsorbent, all the forces acting between the particles are mutually balanced. That means they feel attraction from all sides. But the particles on the surface are not surrounded by atoms or molecules of their kind from all sides, and hence they possess unbalanced or residual attractive forces. The forces of the adsorbent are responsible for attracting the adsorbate particles on its surface. The extent of adsorption increases with increase of surface area per unit mass of the adsorbent at a given temperature and pressure. Enthalpy of adsorption is defined as the enthalpy change when 1 mole of adsorbate is adsorbed on an adsorbent. When a gas is adsorbed, there is restriction in the movement of its molecules. That is, delta S is negative. Adsorption is thus accompanied by decrease in enthalpy as well as decrease in entropy of the system. For a process to be spontaneous, delta G must be negative. So, on the basis of the equation delta G is equal to delta H minus T delta S, delta G can be negative if delta H has sufficiently high negative value, as minus T delta S is positive. Thus, in an adsorption process which is spontaneous, a combination of these two factors makes delta G negative. Adsorption therefore is invariably an exothermic process. In other words, delta H of adsorption is always negative. During adsorption, there is always a decrease in residual forces of the surface, that is, decrease in surface energy, which appears as heat.